We were given a group assignment on the topic concrete defect. Concrete is a mixture material of particles that are tightly linked together, and an industrial material that mimics the characteristic of rock. Any flaw in concrete that result from poor planning, poor execution, poor material, or occasionally any combination of these is referred to as a concrete defect. Wear and tear, overloading, and poor maintenance can all cause concrete fault over time in a building. There are many types of defects in concrete, but today we would like to talk about three main defects that are commonly seen in our daily life.
One of the type of defect concrete are honeycombing that you visibly see in a lot of concrete members and it visible in the image that you see in front of you. So, what is honeycombing? When there are air holes between the cores and the aggregates, a rocky surface known as honeycomb develop on the concrete. This occurs when there is not enough fine materials added to the concrete mixture owing to improper mixing or aggregate grading.
The removal of the concrete shattering or the use of ultrasonic testing methods can generally reveal this. Honeycombing occurs when the mortar fails to fill in the spaces between the coarse aggregate, which result in the voids you see there. The most common causes of honeycombing in concrete members are poor compaction, so the concrete needs to be vibrated while it is being poured. If it have gaps in the formwork, this might lead to a visible honeycombing.
There are also concrete segregation, which refer to the separation of designed fresh concrete from the ingredients, resulting in a non-uniform mix. More specifically, this suggests that coarse aggregates are separated from the mortar due to variation in their size, density, form, and other qualities. Concretes become honeycomb-like due to segregation, which essentially impacts the concrete porosity and strength. Concrete segregation can happen on the job site during construction, which has an impact on the structure's durability. You need to understand concrete segregation if you are building your own home or visiting a construction site.
In concrete, there are mainly two types of segregation and concrete. The first type, say the coarser and the heavy particles tend to separate out or setting down from the rest of the mix because they tend to travel faster along a slope or settle more than finer materials. This type of segregation may occur if the concrete mix is too dry. The second type are grout, which is water plus cement separating out from the rest of the material because of the lower specific gravity. This type of segregation may occur if concrete mix is too wet. A well-designed concrete does not segregate if rightly mixed and batched.
The major causes of segregation in concrete are mainly because the difference in specific gravity of the mixed constituents, different in the size of aggregate, too much vibration of concrete, bad practice of handling transportation of concrete, and the concrete is discharged from a badly designed mixer or from a mixture with worn-out blade. In order to prevent segregation of concrete at the time of construction, especially while using transit mixer, care should be taken the concrete is poured from a height greater than 1.5 meter. Other than that, aggregate should be properly grabbed as it will prevent segregation. And lastly, to improve the viscosity of concrete which prevent the segregation, and anti agent can be used.
When concrete bleeds, free water in the mix rises to the surface and create a cement paste called lanterns on the surface. When free water is present in the mix, it is pushed to the top of the mixture as a result of the settlement of heavier solid particles like cement and water. Like like process is known as bleeding in fresh concrete, while some bleeding is common. Excessive bleeding can cause issues. The longevity of your item might be impacted by how you work.
Now I want to present my part. Bleeding in the concrete mix is caused by the segregation. Heavy aggregate particles that settle down as a result of segregation cause water to rush to the surface and form a layer. Additionally, tiny cement granules are carried upward by the water. Slab and pavement top surface won't be well suited for wear. When the water to cement ratio is larger, bleeding on the surface of concrete will occur more frequently. The amount of fine aggregate and the type of cement used both have a significant impact on the rate of bleeding.
Concrete becomes permeability as a result of bleeding. In addition, while the bleeding process continues, the water buildup results in a water void and weakens the bond between aggregate and cement paste. Concrete loses some of its pumping power as a result of bleeding, can alter the water to cement ratio at the top. Surface finishing is delayed as a result of the water buildup at the top.
Among the strategies for minimizing concrete bleeding is lessen the water content. In addition, use a reduced slump mix. After that, use finer cements. Concrete bleeding can be decreased by adding more particles to the sand. Utilize additional cementitious components such as granulate base, a furnace like GGBFS. Use air entraining as mixture as a last resort. Water reducers often minimize bleeding, but depending on their chemical makeup, they could possibly result in an increase in this rate by enhancing cohesiveness and reducing segregation in the fresh concrete air. Entraining as mixture can also lessen bleeding. And that concludes our presentation for today. I hope everyone could learn a new few things from our presentation. Thank you and have a good day.